Hello, welcome. We are going to draw the development, the true shape, the plan, and front elevation of a truncated cone of base 60 millimeter and vertical height 80 millimeter. And its vertical height has been bisected by a 45-degree cutting plane. So the question reads, draw the development, the true shape, the plan, and front elevation of a truncated cone of base 60 millimeter and vertical height of 80 millimeter and its vertical height bisected by a 45-degree cutting plane. So that's what we are going to use as a guideline to be able to come up with what we are expected to. Now in this case, first of all, we are going to have our plan of our cone, which is a circle. Then we shall draw the front elevation, which will be in a shape of a triangle, although it's a cone, and then we shall truncate it at 45 by 45 degree, a line at the center point of the vertical height of that particular cone. So the first thing is to be able to draw our plan, and our plan, as we said, it's going to be our circle. We are taking that one as our baseline. Then we're starting from there to draw a circle. Now a circle will be of radius 30 millimeter because the cone is of diameter 60 millimeter. So now we shall measure our 30 millimeter and then we draw the circle. That is our base. It is our circle. Now this circle is assumed to be our base for the cone. And then we are now going to draw the vertical height of our cone. And the vertical height, we shall project our center line through the center point of our circle so that it goes vertically up to be able to give us our front elevation. So this one's our center line. So we can just draw it vertically upwards. Can go as far as you want. Then we shall draw our front elevation, of course, above our plan, and therefore it means we can have a horizontal base just above the plan. We have our horizontal base. This is a reference line for the plan. Then we project lines from the plan to meet that horizontal base. So we project this to meet the base. We also project this to meet the base. The next thing we shall do is to measure the vertical height, and the vertical height is 80 millimeter. So we are going to measure 80 millimeter and we transfer it here. So this is our 80. Can come, as you can see, this 8. So this is the vertex. We can call this one point V as the vertex. Then we join it back to the base from the vertex. You can join it. The vertical height, as you said, it is 80 millimeter. So you join it back to the base. Now, because this cone has been truncated by a cutting plane at 45 degrees to the horizontal, or bisected by a cutting plane at 45 degrees, it means it is at the midpoint where the line is going to pass through. Then we have to draw that particular line, and it is that 45 degrees to the horizontal. So we are going to have our midpoint, it is the 40th mark. So we measure from here up to the 40th mark. Now this is our 40th mark with your horizontal plane and a 45-degree set square. You can draw the cutting plane through the point. So this is my cutting plane, cutting through the point. Then from there, we are going to draw or to divide the plan or the circle into 12 equal parts. How do we do it? We take the radius. With the radius, you can stand with it at the end point where the bisector, where the center line meets the circumference, and make arcs on the circumference. What we are doing is we are dividing the circle into 12 equal parts. So these ones are 12 subdivisions. You can join them correspondingly, so that this one and this one, you join them correspondingly. Okay, we have joined that. We can also join this, or we can also join this through the center point. There it goes. Now you can number them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. Okay, then we are going to project them back to our front so that we have lines joining to the apex. So let's join those points to the base, or project them to the base of our cone. There, we bring this in that order. There we go. Again, we can name. This is point 4. This is point 3 and 5. This is point 2 and 6. This is point 1 and 7. This is point 8, 12 and 8. And this one is 11 and 9. The last one is 10. Okay. Now we want to finish drawing our front elevation so that we can have the truncated cone itself. This one, it means we are going to use an outline, because we are assuming these other ones are just but construction lines. So this is our expected cone that has been truncated. So we join. Okay, now we are through with our front, although the plan we are not yet through with it, because we've not included the cut face, this cut face on our plan. We shall do it later. So we are going to join these points of intersection between the base and these lines, the vertical lines, to the apex, so that this one is joined there. Okay, and then this one again, we join it. Now, after joining them to the apex, let me not shrub, the apex, we are going to drop them vertically downwards so that they meet our plan. See, what we are saying is this is the truncation line. We have these lines going to the apex. Where they meet the cutting plane, we drop them vertically downwards, because we want to transfer this face on our plan. We want to transfer it on our plan. So what do? We are going to take our horizontal base together with a vertical edge to drop them vertically downwards, starting from the first one. Here it is, the point of intersection between the outer line and the cutting plane gives us that point. So this point. Then next we are going to drop this. Do the same thing. Come, drop this. Next, this one here. Okay, We look at it where it cuts, then we draw a line. We continue that way. So we have dropped them. Okay, now you'll realize that those lines that have gone downwards vertically, they will be meeting these radial lines at, or this radii at given points. Like for example, starting with the first one that we dropped, it meets it there. The second one is this one here, it meets this radial line and this one here. Let me use a different pen. And then this one here meets it here and here. Okay, and then this one here we shall establish it. This one here meets here and here, and then this other one meets here and here, and the last one here meets there. So we are remaining with this line. We want to know where the curve is going to pass through on this line. How do we now do it? We are going to draw a straight line that is parallel to the base from that point of intersection between the axis and the cutting plane back to our sloping line. Then you drop it down to meet this horizontal axis, this center line. Then we take this radius, then we draw something like a curve where it cuts this line here and here, gives us the 2 points where the curve will pass through. So what we are saying is, we first of all bring this line to our sloping plane horizontally. There it goes. Then we drop it vertically down. We drop it vertically down. There it is. Okay, we drop it vertically down. It meets there. Then we take this radius from the center and we draw a curve. This curve here, you can draw it or we can just make arcs. So this is the curve we are saying. Once we have it, we can establish this point and also this point. So we are going to join so that we come up with our inner part. And how do we join it? We can use what we refer to as the curves, or French curve, which if we don't have, we can use a free hand to join the points, but so long as the curve is maintained to be a fine curve. So we have done our plan for our truncated cone. We have the inner part. Now this one here represents this face that has been cut, and this one represents the outer part from here, the larger circumference. Once we are through with that, we need to do what you call drawing of our true shape. True shape can only be drawn if you view the cut face at right angle. That is, you are drawing a face perpendicular in relation to this face. You draw another shape of the plan on this other side so that it's perpendicular to the cut face. How do we do it? You'll realize that if we have a small space here, it means you'll have to draw it here with the opposite side, because those lines are same. If we pass a line through this point to come this side, it's almost the same thing. So we can try and see whether it will fit here. It fits. So what I will do is, first of all, to draw a perpendicular line to the cut face. How do we draw the perpendicular line to the cut face? It is very simple. First of all, we can first pick this. Okay, this is the face. Now if this is the face, we want to draw a line that is parallel to it. So we can move this face parallel downwards to give some allowance for us to draw the perpendicular line. Let's say this is the movement, so you move it this way. Once you've done it that way, you bring another line, you draw it If this one was sorry, it has fluctuated, we can still repeat. You bring it here and then slightly just move it, you slide it on this side, that manner. Then once you've done that, you come with your line that is perpendicular, and you draw it from this point. Of course, it is the center point. You can do the same with all other lines. So the second line is this one here. You draw it that order. So you continue drawing the lines. So those are the projections. What we shall do is we are going to carry these points individually, follow every line, and then we transfer them. What we are saying is, if you come at this point, because we expect to transfer this point, okay, this one here, you take your compass there, you come with it on the same line here, then you make an arc, okay. Next, we want to do this and this, so we carry it from here, we come here, we carry the first one, okay, the first one, we come with it on the same line, we make an arc, we come back here, we carry the second one, and we come with it here on the reference line, we cut. Next, we want, which one? We want this and this, okay, this and this. So here we are going to use this point from here, the first point on the same line, we cut, we come from there, the second point on the same line, we cut. Next, we want this and this and this, here it is. So we are going to use this, take that on the same line, transfer it, come back, carry the second point on the same line, cut. Next, we want this and this, so we use this as our reference, come, carry on the same line, you cut. Next, we want the other one, so we carry this, come with it, transfer. Next, we want this and this, okay, so we are using this, so here carry this on the same mark. Next, that, okay, same, transfer it. Next, lastly, we want this, so this one here we are using this, so this back here on it, here it is, finish. So we are going to join with a fine curve. We join these points with a fine curve. So what we have drawn is the true shape of the cut face. The next thing we are going to do is to draw the development. How do we draw the development? The development is like we are going to unfold the cone, the front part, okay, the cone, the truncated cone, so that we now have the net. How do we do it? We just carry the same distance, we transfer it. Now let's do it. We are going to carry this and we unfold it, okay, it's like we are drawing a net. So if we draw a net, it will cut through here, so we don't have to do it that way. We have to transfer this point V somewhere here because we need some more space here, okay. It is easier to do it. So what do we do? We are going to first of all transfer this point to come up somewhere here. We can first of all have this line, okay, and then we move it. How do we move it? It should be parallel. So if you want to move it, you can first of all realign And then that's the movement. We have moved it. Here it is. So we can now draw it here. You can as well draw it to any length or measurement you want. Now let's say you want your V to start from here. This is V, okay? So you take your slant height, here it is, and come with it and draw a net. We draw our net. Okay, now we do not know actually the angle subtended by that arc. How do you know it? First, we have to calculate by saying that that angle equals to r over true length multiplied by 360. Our r is 30 because we're using 60 as the base. Our true length is v from this point to here, okay? Or it's like the slant height. And then this slant height here, how do we get it? We use the height and the base. So we are going to use height squared plus base squared, okay? And then we multiply, we take the square root, we multiply by 360 degrees. So this is 30 all over height squared plus b squared. Let's see what we shall get. So when you calculate, you realize that our height was 80 squared plus our base is 30 radius base, this distance from here up to here, because this is 16 and this one becomes that. So it's like we are taking this triangle with height 80 and base 30. So the hypotenuse is this one squared plus this squared, then you get the square root. Here it is, okay? We get it as 85.44, meaning this is the true length. So if you calculate using 360 degrees, you get the angle as 126. So we are going to measure 126 from here. So we measure 126. So 126 passes through this point here. Okay, yeah. Once you have that, we are going to take this measurement, these 12 parts, and you transfer them. Okay, the way they are, we are going to transfer them along this. Okay, they are going to be 12 in number. So we just step, we call them stepping off. So we have stepped them, although you realize that they might not be equal to the last one. Why? Because this is estimation. We cannot say you are stretching this one to form a straight line and gives you the true measurement. So we are going to, because our angle we did it through calculation, we did not estimate, and that's why it is that way. So we can join. So if we want to unfold it from this point, it means you start by having your 4, you continue 5, 6, 7, 8, 9, 10, 11, 12, you come back to 1, 2, 3, 4. That means if you start with 4, you end with 4. Then we are going to carry this from here to every point, okay? Then we bring and draw arcs. So that means the first one is here. Okay, what I'm saying is we are going to transfer these points. This one, this one, this one, this one, this one, this one, and the last one on our net. How do we do it? We just carry these distances and we come back and draw curves. So the first one is, we can start with the farthest one. Then you come with it here and you draw an arc. There's some blurring, sorry for the blurring. I think it's some lens adjustment. Okay. Next is this one. So we pick that, come, draw an arc. Next, the third one. Here it is. We have done this. Now this one here. Then you take that distance and you transfer this. Next, the center one. Okay. So we take this, transfer. Next, this. So you have transferred. Now what we are going to do, the next thing is we want to locate the points, so that like for the first one is 0.4. Here it is. So we come back here. This is the line, okay, the last line. We look for where 0.4 is, we put a dot. Like in this case, we are going to have a point there, and the same line, we put another one here. Next is 3 and 5. These are the lines. So 3 and 5. These are the lines 5 and 3 on the same line. Where is 3? Here it is on the same line. Here it's 3. Next is 2 and 6. 2 and 6. 2 and 6. This line, we look for where 6 is. Look for where 2 is. Here it is. Next is 1 and 7. So this line, we look for where 1 is and where 7 is. This is 1 is here. Okay. Next is 12 and 8. This one. So on this line, we look for where 8 is and 12 is. This is 8 and this is 12. Next is 11 and 9. So we look for where 11 is and 9 is. Here it's 9 and here is 11. Then lastly is 10. So on the last one, we look for where 10 is. Then all those points can be joined with a curve. Okay, we join them with a curve. So you have joined with a curve, and also this other end, because it's a net diagram for a development, and the outer part will also be joined. So that is what we were supposed to draw. As you can see, we have our plan, our front, our true shape for the cut face, and our development for the truncated cone. Thank you very much for attending to my lesson today. Consider subscribing to my channel. Have a nice day.